What's up, everybody? It's Hutch here, and this is Module 5, Real Number System. Okay, all your notes are right in here. Let's go ahead and start off with this real numbers image here. Now make sure in Notability, in Schoology, you're checking out which lessons you're supposed to be doing so that you don't go too far. All right, now real numbers. Okay, real numbers, what I want you to see here includes everything. Every known number that exists is in the real number system. Okay, so let's go ahead and break down the different categories of real numbers. So I want you to think about like you're a baby, now maybe you're 2 or 3 years old, you're a toddler, and if someone said to you, hey, can you count to 5? What would you say? You would say, oh yeah, sure. You would say 1, 2, 3, 4. So notice you don't start off with 0. So the first step is these natural numbers, or I want you to go ahead and put in parentheses counting. Okay, so it's sort of like a toddler counting 1, 2, 3, 4. So that's the first type of numbers. Then we go ahead and we add the number 0. So it's like, oh, later you learn that 0 exists also. Okay, so just go ahead and circle the 0 and we'll write 0 in parentheses. So these are little hints. Then we get to integers and we realize, oh, there's stuff to the left of 0. There's negatives. So integers in parentheses, I just want you to put NEG. So it's all positive and negative numbers. So you take your whole numbers and their opposites, and it's all negative. We could put negative and positive numbers. Okay, and then we have rational numbers. Rational numbers is the next one. And if you can basically create a fraction, okay, because notice integers and whole numbers, those are not fractions. They are whole. They all create positive and negative numbers that are whole numbers. They are not fractions, okay, or fractional amounts. So all of a sudden we have 3/4, which is not a whole. We have 7/8, things like that. Okay, notice that decimals that repeat are okay. Okay, that is part of something because this is 45/99. Okay, that is a fraction. It's 9 and 45/99. Okay, and so repeating decimals are okay. So rational numbers, your hint for this one is just going to be frac. Okay, if you can create that number with a fraction, then it is a rational number. Okay, our last category is irrational. I want you to underline ir. It's a prefix that just means not, so it's not rational. That means that it is going to have two characteristics, or one of two characteristics. It does not stop, or what we say is terminate. Think about if you got terminated from your job, it means you're done with your job. So the decimal does not stop, it does not terminate, and it does not repeat. Okay, so if you see this exist, okay, it does not repeat and does not terminate, then it's an irrational number. So like pi 3.14, and it goes on forever. Square root of 2, square root of 3, 10. Also some things like imaginary numbers that you'll learn about later, or the letter E that represents a number. All those are irrational numbers. Okay, now be careful with your calculator. If you type in an irrational number, so for example, square root of 2, you can see it looks like it stops, but if you don't see it's repeating, then assume that it goes on forever and does not stop. Okay, calculators truncate or cut off automatically, so don't assume that it stops. Okay, just because you see it on the calculator stop. All right, so those are the types of numbers and the hints of how to remember them. Here's your learning goals, as well as the lessons for this module, and a whole bunch of the vocabulary terms that we're going to be using throughout this module as well. So let's go ahead and start off with Module 5-1, which is square numbers and square roots. The biggest thing I want you to see and understand are the fact that squared and a radical sign, okay, are opposites, okay? So square root and squared are their opposites. So like when we're solving for a variable in an equation, you know, if we have a +4, we always do the opposite of -4 to both sides. In this case, if we have x squared and we want to get rid of that, okay, so let's say we had something like this, I could take the square root of that to both sides, and it's going to get rid of my squared, okay? And then I would end up with 2 equals x, okay? So that's one big thing you want to be aware of with the squared and the square root symbol, is that they're opposites. The other thing I want you just to know, so that we're giving you some extra information, is that even though you don't see it, it's invisible. It has a little 2 here, okay? It's just sort of the generic square root, so we don't usually write the 2, okay? But that's why it's called square root, because it has what's called an index. Can you write index here? An index of 2. So in addition to that, you could have a cubed root, okay, which means a number times a number times a number creates that inside number that you would see, okay? So just be aware of those couple things. All right, so let's go ahead and explore some perfect squares, okay, meaning if we do a 1 times a 1, okay, think about a 1 by 1. That's a square, right? Okay, so these create perfect squares. Okay, so 1 squared equals 1. Okay, 2 squared, or 2 times 2 equals 4. Okay, sort of picture a square with an area. And we can actually slide down here real quick. It says, can you draw 2 square numbers? So let's just draw the 2 by 2. In Notability here, you can draw a square and then hold it. There we go. So this just means we have a length of 2 and a width of 2. Okay, so it's a 2 by 2, or 2 squared, which is what makes a square. Duh, that's why we call it that. Okay, just like a cubed would make a cube. It's a length, a width, and a depth. Okay, or a length, depth, and a height, if you want to think about it that way. All right, so here's this, and this is 2 squared, or it equals an area we could think of as 4, okay? So that's what that looks like. So I want you to go ahead, back up to here. You don't need to expand that out for each of these. I just wanted to start it off with that. So 3 times 3 is 9, and then you can go ahead and continue on. Once you get to, above 12, you'll probably need to use your calculator, which will give you some good practice. So you would just head to Desmos, and you're going to do 13, and then you can hit the a squared, and it'll automatically show you that that is 169. Okay, so go ahead and fill out the rest of the table. You can pause this video and then hit play once you're done. Okay, all right. I'm going to draw one more square here. Okay, you can pick any one you want. Just make sure you get the square drawn. And I'll go ahead and do the 4 by 4, okay, which is 4 squared. And we know 4 times 4 equals 16, okay? So there's the representation of that. Now, one of the things that we want you to be aware of, if we take a look up here, it says taking the square root of a perfect square will give you the dimensions of one side of the square. So take a look at what that means. I have 16 here. If I take the square root of 16, that equals 4, which is one side of the square. So just be aware of how that works and what it's giving you, okay, from a visual standpoint. All right, so let's go ahead and find the square root. So in our head, we want to think what times what equals 9. And so we say, well, 3 times 3 equals 9. So the square root of 9 is 3. What times what equals 64? Well, 8 times 8 equals 64. So that's the square root. Okay. You can also check by thinking 8 squared. Does that equal 64? Yes, 8 times 8. Okay. All right, let's go ahead and find the square roots. I want you to go ahead and write these. You just do a little like check mark like this and then straight over. Okay. Okay, so check mark and over, and that's the square root symbol. Okay. All right, now square root of 169. Well, I know 12 times 12 is 144. All I have to do is look up at my chart and I can see 169 is right there. So 13 is the square root of 169. What times what equals 81? 9. What times what equals 676? Well, I have no idea because I didn't finish filling out the chart like you did, but you probably have an answer already. I'm going to hit square root of 676, and I get 26 like you would have already known. All right, now let's go ahead and evaluate. A couple things to remember when we take the square root of things, okay? If the negative is outside, we're going to do the square root and then make it negative. Okay, a negative on the inside cannot exist because think about this for a second. If I have, like 4 is an easy one, square root of 4 is 2, right? If I put a negative inside there, is there any number times itself that can equal a negative? Well, think about it. 2 times 2 equals a positive, and negative 2 times negative 2 also equals positive. So that's not possible. I can't make the negative. Okay, and so this is what's called an imaginary number, or we use that symbol of I. So just be aware of stuff like that, okay, and be careful. All right, so 225, you can already look up at the top. I'm just going to go ahead and plug in square root of 225. So it's 15, and then we need to make it negative. Okay, all right, square root of 144 is 12 times 12 there. And then we have this. If you can solve inside the square root, then you should do that. So we have 2 minus the square root of 36. And then we're going to go ahead and solve that first. So square roots act as like grouping in GERMDAS. Okay, and so we're going to take care of this first. And we have 2 minus 6 times 6 is 36. I'm going to KFC that really quick. Different sign subtract, and we have a negative 4 as our answer. Okay, so that's how you're going to work through evaluating those as well, okay, following order of operations. All right, now, if you're to move on to 5-2, then here you go. Okay, all right, so our key concepts, we already talked about the different types of numbers in the real number system. Let's go ahead and practice reminding each other. Okay, all these things. So I wish these were in a different order because really which one out of those is the first thing that you would learn as a toddler? If you said natural numbers, you're right. Okay, these are the counting numbers. Okay, so 1, 2, 3, ... Then we learn whole numbers, and that includes the number 0. Okay, so our hint is 0. 1, 2, 3, ... Okay, then we learn, oh, there's negative numbers also. Okay, so integers are negative and positive numbers, so this would be the next one. Okay, and then we have all rational numbers. Those are ones that can be written as a fraction, so that's your hint for that. And then irrational are numbers that are not fractions. Okay, remember they don't repeat and they don't stop or don't terminate. All right, so let's go ahead and look at this. It says repeating decimals are actually rational numbers because they can be written as a fraction. So remember the trick was the number that's repeating, you put that number on top and put it over 9, and that's how you create that. So you can see the number repeating is 27, so we have 27/99. We've already talked about this before. The number repeating is the 5, so what would that be? 5/9. And the number repeating is this, okay, 1, 2, 3. But remember that you need to put the amount of 9s for the amount of repeating numbers, okay? So 123 over 999, you can see that here, over, oopsie, divided by 999, and there you go, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so let's take a look at this. It says this number is also rational, but it doesn't follow this shortcut, and that's because you have this 2 and then only the 7 is repeating, and so our trick doesn't really work for that. So what you would do for something like this is let's just go ahead and see what this one could be. So 0.27 with the 7 repeating. Let's see. Let's try this first. It's 13. No, we need 0.27. So 13 fifteenths, 0.86. 13 twelfths. Let me see my notes for this one. 0.27 with a 7 repeating. Let me see if I can find one of my old ones here. Oh, here we go. Let's see what I put for this one. 5/18. Okay, so let's go ahead and plug this in here. 5/18. There you go. 0.27 with the 7 repeating, and notice that they rounded the end, okay, to an 8. So you can see how the calculator behaves with decimals that repeat, okay? And so this was 5/18. So let's put equals 5/18, okay? But let's go ahead and show what the calculator shows. Okay, and we can show 0.277777, and then we can just put an 8 at the end like that. Okay, just to be aware of how the calculator might show it, and so you're going to have to understand that the calculator is truncating or cutting that because it goes on forever. All right, let's go ahead and look at these irrational numbers now. Remember, irrational, if we look back up at our picture here, irrational are any numbers that do not terminate and do not repeat. Okay, so back down to this pi, and let's go ahead and write the pi symbol. It's 2 lines like that, and then a little squiggle. Is irrational because it, what were the 2 things? Does not terminate, so goes on forever, and does not repeat. Okay, so those 2 things. Why is this number irrational? Take a look at it. Do you see any repeating? Nope, because it, and we can put ditto marks, does not terminate and does not repeat. Why is the square root of 35 irrational? Well, let's see what it looks like. Okay, look at that. 916079783 random. Okay, so let's go ahead and write a little bit of that down. So 5.9160799783, and we're just going to do ... That's irrational because the same reasons. Does not terminate, does not repeat. Okay, so what other types of square roots will give you an irrational number? Well, let's try some. Okay, square root of 1 is 1. That stops. Square root of 2, okay, look at that. Okay, so square root of 2. Try to find a couple other ones real quick. Okay, let's see, square root of 3. Yep, that's another irrational. Let's try square root of 4. Nope, we know that's 2, right? Square root of 5, though. Yeah, look at that. Okay. All right, what other numbers, types of square roots will give you a rational number? We already know some rational ones. So we know square root of 1 is a rational number. Square root of 4 is 2. Okay. So there's some square roots that give us rational numbers. Okay. Now we're going to head to this chart. This is called classifying. Classifying means can you put them into the categories. You are going to have to do this on your test, so really, really focus on these tips that I'm giving you. Okay. The first thing is we want to make little notes above this. So remember, when we're a toddler, natural numbers, okay, are our counting numbers, and we just say 1, 2, 3, ... Okay, then what's the next thing we learn? Well, we learn 0, 1, 2, 3, ... Okay, so our hint is the word 0 is added on here. Okay, then what else do we learn? We learn all the negative and positive numbers, okay, of the ones that we already know. Okay, so the opposite of all the whole numbers. And then we get to rational numbers, and these are everything we've learned plus anything anything that can be written as a fraction. Okay, and this includes repeating decimals. And then irrational, we want to be thinking about what that means. Okay, and so these are numbers that are not fractions. And what were the two things? Okay, does not, we could say terminate or stop. Okay, and does not repeat. So these are notes you have to remember. Okay, and then real numbers are everything. Okay, so all numbers are real numbers. So right away, if I'm going to do this chart, no matter what, I'm checking off every single one of these because every number I know is a real number. Okay, and then I'm going to go through and start working my way down this list. Okay, so let's think about all of our irrational numbers. So does not stop and does not repeat. Well, 8 stops. Okay, 2/3. Let's look at that. So we would want to write fraction 2/3. Okay, so that one, the 6 repeats. Okay, so it's not an irrational number. Okay, and then the other recommendation I would make for you is write what it actually is so we can see. Okay, so 2/3, if you look, was our 2/3 was 0.6 repeating. So 0.6 repeating. Okay, and so we're going to go through and look at this a little bit. Okay, so that one's not irrational. Okay, let's look at 2.3. Well, that does stop, so that's not irrational. Okay, what about 25/5? Well, I'm pretty sure that 25 divided by 5, okay, is 5, but it's negative, so this just equals -5. So I want to write down what it is to simplify it a little bit. Okay, square root of 0, let's check that out. Square root of 0, 0 times 0 is 0. Okay, so this just equals 0. What about square root of 91? Okay, this is 9.5, blah, 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 blah. 9.539, da, 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 da. Okay, so it does not stop and does not repeat. So this is an irrational number. Okay, let's do our -4 to the 4th power. Okay, now remember that's -4 times -4 times -4 times -4. Okay, so I have to put this in parentheses. So -4 to the 4th power. So I'm going to have to hit this a to the b so that I can put in the power that I want. So this equals 256. Okay, and then we have 4 to the 4th power. That doesn't have the negative in parentheses, so that's just 4 times 4 times 4 times 4, then make it negative. Okay, so this is 4 to the 4th power, 256, and then make it negative. So you have to know how that works too, and we've talked about that a lot. All right, so now that we see all the numbers, we can start thinking through each of these pieces here. Okay, so are there any others that do not stop and do not repeat? Okay, no, everything else stops. So there's no more irrational. Now let's look at the rational category. Okay, rational is anything that could be written as a fraction. Okay, so this could be 8/1, right? That could be a fraction. Okay, 2/3 is a fraction. Okay, this here is 2 and 3/10, right? Okay, so that can be written as a fraction. Okay, we already see this one as a fraction. Can the number 0 be written as a fraction? Yeah. Okay, and then we have that weird one. Irrational cannot be written as a fraction. 256 could be written 256/1. And -256 could be the same thing over 1. Okay, so those are all rational numbers. All right, now let's go to our next category, which is integers. So see how I'm working my way backwards. Okay, so are there any that are negative and positive numbers, okay, on this list? Okay, so the number 8, okay. Now, here's the thing, though. These ones, okay, they have to be all whole numbers and their opposites, okay? They can't be partial numbers, okay? So all positive and negative numbers that are whole numbers, okay, not fractional parts. Okay, so 8 over 1 we know isn't a fractional part, it's a whole number. Okay, but 2/3 is not a whole. Okay, 2 3/10 is not a whole. Okay, 25/5 is just -5. So is that a whole number and its opposite? Yes. 0, is that a whole number and its possible opposite? Yes. Okay, the irrational does not work for anything. 256 is a whole number and or its opposite, and we actually have the opposite of -256. Okay, all right, so now we're looking for only the whole numbers with 0, so 0 and up. Okay, so yep, 8, I'll say that if I do that. 2/3, nope. 2 3/10, nope. -5, will I say -5 if I start at 0 and count up? Nope. Will I say 0? Yes. I won't say that. Will I eventually say 256? Yes. Will I ever say -256 if I start at 0 and count up? No. All right, now let's do the natural. These are the toddler ones. If I count 1, 2, 3, I will say 8. Okay, what else? Will I say 0 if I start counting at 1? Nope. I'll eventually say 256, but that is it. Okay, so this just takes a lot of thinking to go through, but that's what you end up as your answers. Okay, all right, let's head to Module 5-3 if you're working on that today, and take a look at this. So when you're going to evaluate a square root, sometimes you get a rational number, and sometimes you get an irrational number. So remember, some rational square roots are like the square root of 4, which equals 2, square root of 9, which equals 3, but some irrational ones are things like the square root of 2, okay? That doesn't work, okay? Or the square root of 3. If I do square root of 3 in Desmos, you can see I get the non-terminating and non-repeating decimal, okay? All right, so let's go ahead and take a look at this. We're estimating, and that means that we want to be able to do this sort of without a calculator. You're making your best guess, okay? So what you're going to do is this strategy, okay? The square root of 10, okay? If we look here, the square root of 10 is a decimal. So there's no way for me to know what the answer is in my head, but I can sort of guess. So I'm going to pick the closest perfect square, and I know the square root of 9 is going to make a perfect square, 3 times 3, okay? And then I'm going to pick the next highest one that I know, okay? And so if I think about 3 times 3 is 9, so I could put a 3 here. And then 4 times 4 is 16, okay? So all you have to do is think of the next one up, okay? And that's 4, okay? And so I know that this is somewhere, the square root of 10 is somewhere between 3 or 4. What I want you to do is I want you to circle what we're probably closer to. So let's think about this. The square root of 10. Is it closer to the square root of 9 or square root of 16? Well, 9 and 10 aren't very far apart, so it's definitely closer to this. Okay, so if we split this up between 3 and 4, we have what? 3.1, 3.2, all the way up to 3.9, right? And then we get to 4. So if you had to make a guess, I mean, we're really close to 10 if we choose the square root of 9. So I would guess somewhere in this like 3.1, 3.2. So let's go ahead and look at what it was. Do you see how it was 3.1? So we can make a pretty good guess that way. Okay, let's go ahead and try the next one. Okay, what do we think an estimate is of the square root of 26? So the first thing I do is just think about my multiplication facts. So like 4 times 4 is 16. That's not really close to 26. 5 times 5 is 25. That's really close. So I'm going to go ahead and say the square root of 25, and that equals 5. And then I'm just going to write the next number up. Okay, and think about what that squared would be. So 6 times 6, or 6 squared, is 36. And then I want you to just look at the space between these two numbers, okay, and start thinking about which square root is closer to 26. Well, obviously 25 is really close to 26. So that means my estimate or my actual answer has got to be pretty close to 5. Okay, so I would guess maybe 5.1, something like that, because it's only 1 away from 25. Okay, so let's go ahead and actually see what it is. So the square root of 26, look at that, 5.09. So we're really, really close. So that's how you can make an estimate. There's no way for you to know for sure what it is, though. Okay, so let's try some things to find an estimate for the square root of 8. So 4 times 4 is 16. Now that's too high. 2 times 2 is 4. 3 times 3 is 9. That goes over. So if I choose 3 here, that would be the square root of 9, right? Okay, that's pretty close. So that means down here I'd have to have 2. So you're just finding the one number above and below that'll work. So 2 times 2 creates the square root of 4. Okay, so what is 8 closest to? Square root of 9 or square root of 4? Well, it's definitely closer to the square root of 9. So that means that my decimal for the square root of 8 has got to be really close to 3. So maybe I guess like 2.9 is my guess. So let's go ahead and see how close we are. Square root of 8, look at that, 2.82. So we're pretty close, okay? All right, let's go ahead down to here. You can always pause and try these out or just follow along. Okay, so 2 times 2 is 4. So I'm going to put a 2 here and actually put what that makes, so square root of 4. Okay, and then I'm just going to put the next number up. So 3 times 3 is the square root of 9. Okay, so what's 5 closest to? Okay, is it closest to the square root of 4 or is it closest to the square root of 9? Okay, well, 4 and 5 are pretty close together, so it's going to be closer to this end. Okay, so what, maybe 2.1 or 2.2? I'll go ahead and just do 2.1. Stay consistent since it's 1 away. Let's see, square root of 5. Yep, 2.23. There wasn't a big gap, which is why 2.2 would have probably been a better guess. All right, square root of 33. I don't know what that is, but we can estimate for sure. Okay, so think what's really close to 33, what square. Maybe 5 times 5 is 25, 6 times 6 is 36. Oh, that's really close but high. So I'm going to do 6 times 6 is 36. And that means I'm going to pick 5 here. So 5 times 5 is 25. So what are we closest to? We're definitely closer to here, but we're not like crazy close. So between 5 and 6, I'm going to say the answer to the square root of 33 is maybe 5.8 is my guess. So let's see. Square root of 33, 5.74, pretty darn close. Okay, all right, let's go ahead and try this one. Square root of 15. 3 times 3 is 9, 4 times 4 is 16. That's over. So 4 is my closest one here, which means 3 is going to go here. And 3 times 3 is 9. Okay, so what are we closest to? We're definitely closest to this side. We're going to circle that. And so between 3 or 4, we're probably, the square root of 15 is probably 3 point, let's go with the 3.8 this time instead of 3.9 and just see here. They're just estimates, so if you're just a little bit off, then you're going to be good. So square root of 15, oh, look at that, 3.87. Okay, so it was pretty close to 3.9 also, so good estimate. All right, so let's go ahead and now just do it here. If they just say estimate the square root, this is what you would do, is that process. And so you would just think, okay, 6 times 6 is 36. That's really close. So I'm going to put the 6 here and write 36, just like we did. Okay, it's using that strategy to figure it out. So that means 7 goes here, and 7 times 7 is 49. Okay, so what is the square root of 38 closest to? Definitely closest to 36. So I'm going to say my official answer is going to be 6.2. Okay, and remember, it's just between 6 and 7, and you guess your closest guess. Let's see what the actual was. Square root of 38, 6.16. So I was really close. Okay, I don't want you to write the official answer, but definitely peek and see if you're close. All right, so square root of 45. 5 times 5 is 25. That's way too low. We want to get as close to 45 as we can. So let's see. 7 times 7 is 49. 6 times 6 is 36. Okay, so I think those are my numbers. 7 times 7 is 49. 6 times 6 is 36. We want to find the one above and one below. Okay, what's 45 closest to? I think it's closest to 49 here. It's only 4 away. Okay, so it's not really close to 49, so I don't want to pick like 6.9. Maybe we do a 6.7 is my guess. Okay, my estimate. So let's see, square root of 45. Oh man, I got that spot on. All right, square root of 160. So I know 12 times 12 is 144. 13 times 13, let's see, 10 times 10 is 100. 3 times 3 is 9. Let's see, we got 9, we got 3, 0, 3, 1, 169. Okay, so I think this is going to be a 13 on this side, which gets me the 169. I could have looked back up at my top thing. So square root of 169, make sure you include that square root so you're being accurate. And then this is the 144. Definitely closest to this, so I'm going to say 12 point. It's not right next to it. I'm going to go with the 12.7 again, that 0.7 as my guess. So let's see. Square root of 160 is 12.64, so pretty close. All right, square root of 200. Okay, so we're going to try out some things here. I'm gonna use a calculator, but I'm still gonna do it the right way with my guesses. So let's do like 15 squared is 225. 14 squared, 196. So there we go. I got a lucky guess. So 14, 15, 14 squared is 196. And 15 squared is 225. Okay, so 200 is pretty closer to 196, square root of 196 for sure. So 200's got to be 14 point, I'm going to go with 14.3. Okay, because it's not super close to 196, but it's pretty close. So that's my guess, 14.3 for square root of 200. 14.1, I was a little off, but it's an estimate. We're still pretty good. All right. So the last part of this is find the estimated value of each letter, okay? And I want you to try to do it without a calculator, and because it is estimating, okay? So just do your best. We're creating decimals here. So square root of 18, we know 4 times 4 is 16, so I'm doing my same little notes here. 5 times 5 is 25. We're definitely closer to 16, so my guess for this is 4.2 is what I think that is. Okay, so that's going to go down here. I'm going to put a mark here and label this A. It says graph the values, so I can't put an A. I have to actually write square root of 18. All right, so B is square root of 10, so let's go ahead and do our guess here. 3 times 3 is 9, so I'm going to put my 3 here, square root of 9, which means I put my 4 here, 16. We're definitely really close to 9, so I think we're at like 3.1 is my guess. So that would be like right here, so square root of 10. So you can see how I'm problem solving through this. Square root of 3, well, 1, square root of 1 is 1. Square root of 2, or 2 squared is 4. So square root of 4 is 2. I'm definitely closest to 4, so I'm going to say like 1.9 for this one. So that's actually way down here. I'm going to say square root of 10. Square root of 3, not 10. And then d, well, we know pi is 3.14, right? So half of that, half of 3.14 would have to be like, like 1.5 is half of 3. So like I'll just put about 1.5 for this one, okay? Because really pi is pretty much close to 3, and half of 3 is 1.5. So let's go ahead and use that. So we're gonna, for right here, we'll put pi divided by 2, and then square root of 90. So let's see, like 10 times 10 is 100, 9 times 9 is 81. So I think we found our stuff here, right? So square root of 81, square root of 100, 90. Ooh, 90 is pretty halfway between both of those. So I'm going to go with a flat 9.5 on this one. It's a little closer to the 81, so maybe 9.4, but I'm just going to stick with the 9.5 for that. Okay, so 9.5 all the way down here, square root of 90. Okay, let's just see what that one was out of curiosity. Yep, 9.48, really close to 9.5. All right, so there's my locations on there. All right, let's go ahead and move to the next one. These are all rational, they're letting you know. Evaluate by finding the square root, okay? Then plot them on the number line. So for these ones, we're actually gonna go ahead and do it with a calculator, okay? Because it doesn't say to estimate, so we're gonna go ahead and calculate these ones. So let's get practice plugging those in. So square root of 1.21 is 1.1. So 1.1 times 1.1. So we're just going to go ahead and write that there. I'm going to go ahead and evaluate all these first, just so I have it done. I'm going to do square root of 2.56. Half of that is 1.6, and then we're making it negative, okay? And then square root of 36, well, I know 6 times 6 is 36, so it's going to be a decimal with 6 there. Probably 0.6 times 0.6 equals 0.36. But let's go ahead and see here. 0.36, yep, there we go. 0.6, so some of these you might be able to know. Okay, we know 3 times 3 is 9, but there's 2 decimal movements, so it's going to be 0.3 times 0.3. But let's go ahead and do this. Remember, we have a negative on the outside, and then the square root of 0.09. So that is negative 0.3. Okay, so the square root of the 0.09 is the 0.3. Then we make it negative because of that. Okay, all right, so there we go. Just be careful with things like that, and we can go ahead and it says plot the values. So again, we're not putting the numbers, we're putting the values. So our negatives are obviously going to be first. So negative 1.6, remember that's going negative 1, negative 1.5, and then negative 1.6 is right here. So this is negative square root of 2.56. Then we have our negative 0.3, should be right here, which is negative square root of 0.09. Then we have our 0.6, which would be like right here, which is the square root of 0.36. And then we have f is 1.1, which would be right here, 1.21. Okay, so there we go. We got everything plotted. Okay, all right. Last lesson here, if this is the one you're working on now, Module 5-4, how to remember the correct order to evaluate expressions. Well, remember we use GERM DAS, okay? Grouping, exponents, roots, and that's sort of order of left to right, multiplication, division, addition, subtraction. Okay, because exponents and roots are really, you've learned the same thing, they're opposites. What category does the square root fit in? It's going to be in our exponents roots category. Okay, so let's go ahead and solve through these following those rules. Okay, so according to GERMDAS, okay, we're going to take care of our exponents and roots, and really under the square root is sort of like a grouping as well. Like we have to do that first. And so we're going to I like sort of just like, you can sort of just cross that out, write what it is. So 6 times 6 is 36. So really we just have 6 divided by 2, and 6 divided by 2 equals 3. Okay, so sometimes it's okay to make a little note, okay, and just sort of solve that. Okay, this one here, so square root of 81, what times what equals 81? Well, this is 9 plus 7, but then we make it negative. So I am going to bring that down proper. Evaluating expressions, different sign subtract, and we have a negative 2 as a final answer. Okay, let's go to this one. Coordinate order operations. We're going to take care of the work inside the square root first. It's sort of behaving like grouping for us, okay, right? So let's do an official rewrite. We have 29 plus 7, which would be 36, minus 15. Don't accidentally bring this over. Okay, these are separate problems, and you have to take care of this first. Okay, so next up is taking care of this. So we end up with a 6 times 6 is 36. Make it negative. Minus 15. I'm going to KFC that real quick. Same signs, add and keep. So 15 plus 6, keep it negative. And we have negative 21 as a final answer. Okay. All right, let's head to this one. Okay, we're going to take care of all of our grouping with our square roots first. So square root of 64, well, think what times what is 64? Well, 8 times 8 is 64, but to have two decimal movements, we have to be doing 0.8 times 0.8. So this whole thing just equals 0.8, okay? And then the bottom one, how would I make the 1? Well, 1 times 1, but I need two decimal movements, so it's going to be 0.1 times 0.1. So this is 0.1. Okay, I am going to do a rewrite just to organize things a little bit. So we have 0.8 plus 0.25 over 0.1. Okay, now remember, in a numerator, those are sort of in invisible parentheses. We don't want to forget that. You can use a calculator for this if you want. Doesn't really matter. You do need to be able to show the work. Okay, and so we have 1.05 over 0.1, and so now we can go ahead and hit answer divided by 0.1, and we have a final answer of 10.5. Okay, all right, let's go down to our last little bits here. Evaluate the algebraic expression. X equals 7, y equals negative 3. You must show your work. So remember, when you plug these things in, we put them in parentheses. So we're going to do a full-blown rewrite here. We have a big square root over everything. So x is 7, so we're going to do a 7 squared, okay, and it's this entire 7, plus what is the y? This is why you want to use the parentheses, especially with the negatives. It's the negative 3 squared, so that's a negative 3 times a negative 3. Okay, so just be careful with those squared exponent rules. Okay, we got to take care of exponents first. Okay, so when we're doing our germ DOS, okay, we have grouping, and then we have any exponents, and then we'll take care of the roots. Okay, because the exponents are on the inside. Okay, so let's do a rewrite here. Okay, 7 times 7 is 49, plus negative 3 times negative 3, okay, you could also pull that out like we practiced before, is 9 plus 6. So now we can go ahead and combine all those like terms, right? I'm going to do it with a calculator because I don't want to make a mistake, even though it's pretty easy to solve there. So we have square root of 64. What times what equals 64? 8 times 8 equals 64, and there we go. Okay, all right, let's go ahead and evaluate this one, but notice this word, it says estimate the value. So something's going to be a little bit funky on this, I'm guessing. Okay, notice where this cuts off and be aware of that. That's really, really important. The square root symbol does not include the minus 20 at the end. So I'm going to do a rewrite with our new information. So we have a minus, and then in parentheses, the negative 4, plus 3 times 5, and then keep it really far away, minus 20 at the end. So let's go ahead and start solving. Okay, I'm going to go ahead and I have a -1 times a -4. So this right here is just 4 plus 3 times 5. Now, we still have to do order of operations. So when you're thinking about your germ DOS, okay, I'm inside this almost like grouping, okay, of the square root here. So I can't do the roots yet, okay? I'm still taking care of the grouping in here, okay? So sometimes square roots act as grouping. So the first thing I have to take care of is the multiplication, okay? And so we have 15 here. I'm just going to maybe just write it as a little note, okay, because we can do this quick work here. Then we have 15 plus 4, so 15, 16, 17, 18, 19. So we have the square root of 19. Now, I don't want to lose my minus 20, minus 20. It's easy to focus and lose that, okay? So we need to do the square root of 19 minus 20. Now, the problem is I don't know the square root of 19. That's why it said estimate, okay? So we're going to do what we've did in our estimating lesson. We got to think through the square root of 19. So square root of 19, let's sort of think through this. 5 times 5 is 25. 4 times 4 is 16. So it's somewhere between 4 and 5 because 4 times 4 is 16. 5 times 5 is 25. 19 is, let's see, 16. We're 3 away here. 19. We're 6 away here. So we're definitely closer to 16. So let's just say like 4.2 is our estimate minus 20. So if I KFC that, we're talking about 20 minus 4.2, 20 minus 4.2, and my estimate, I'm going to put an approximate symbol, is 15.8. Okay, now let's see what the square root of 19 actually is. 4.35, so not bad. Okay, all right. So let's go ahead. Another option would just be to do the square root of 19 if you had your calculator, and so you could write 4.4 maybe plus the negative 20, and go ahead and do the 20 minus 4.4 and get the negative 15.6 instead. Okay, so make sure you have your negative there, and I would definitely do an approximate symbol there. Okay, all right, so that's how you would tackle something like that, and that's your module.